Hi everyone, welcome to this channel. Today we are diving into an interesting topic, how regression model can streamline engineering workflows. We will explore this in the context of a real example, assessing the settlement of a shallow foundation. In traditional geotechnical engineering, engineers typically rely on established equations, like the one recommended by Ming and Polos 1999, to predict how a footing will settle under load. For instance, the settlement of a flexible circular footing is determined using a combination of factors, including the input variables, applied load, footing diameter, Poisson's ratio, and Young's modulus, as well as three inference factors. In this example, we will focus on the inference factors, IF, IE, and IG. The foundation flexibility inference factor, IF, is approximately given by this equation, where EF is the footing Young's modulus, ESAV is the average soil Young's modulus, and T is the footing thickness. The second inference factor is the foundation embedment factor, IE, which is approximately given by this equation, where ZE is the depth of embedment of the footing base below surface. However, for the last inference factor, IG, we need to refer to this design chart. It seems that the train of associated equations is broken here. This is a missing piece in this puzzle. Now, think about obtaining the value of Ig manually from this log scale chart. It can be time-consuming, and let's be honest, human error can creep in. That's where regression model comes in. The task here is to find a closed form equation for Ig. Before I demonstrate how to implement double regression to find the closed form equation, I need to mention that integral solutions for the inference factor Ig are indeed available, as detailed in the works of Davis and Polos 1968 and Ming and Polos 1999. While it remains a good practice to perform numerical iteration to evaluate settlements precisely using the elastic displacement theory upon which this design chart is based, this regression method does not aim to replace the original integration method. Instead, it offers an alternative to both the integration method and the traditional graph reading method, establishing a closed form equation that simplifies computation while preserving accuracy. Alright, let's get started with the regression exercise. Step 1. We need to prepare a dataset. I would like to introduce this online app, which helps extract data points from the design chart. The data points are saved in an Excel file for further processing. Step 2. Model selection. For regression, we can choose from linear to nonlinear techniques. In our study, although multiple advanced methods are available, we focus mainly on simple regression algorithms. From observation, you may notice that the curves on the chart exhibit a characteristic S shape regardless of the value of h over d. The parameter beta is plotted on a logarithmic scale using base 10, and the expected form of the equation is shown here. This is a kind of hyperbolic function or sigmoid function. Here, I adopt a modified sigmoid function, so that the outputs are within boundaries in concern. This modified sigmoid function introduces three additional constants, m, n, and k. For fitting each curve with a specific value of x, there is a corresponding combination of m, n, and k. Our next task is to find these constants using a nonlinear regression model. Step 3. Training regression model. I'm going to use Python codes with the aid of machine learning libraries such as scikit-learn and scipy to train a regression model. A good model should be able to minimize the error between predicted result and actual measurements. As such, R2 scores are a good indicator to evaluate the model performance. Here is an example of the Python scripts. I create two variables, that is an independent variable beta and dependent variable ig. The program reads the Excel file for h/d equals 30 and stores the data into a temporary data frame. Then I use string test split to divide the data into training and testing sets, dedicating 10% of the data to the test set. I also set random state equals 42 to keep our split consistent for reproducible results. After that, a nonlinear algorithm is set up to fit this particular curve. Three constants corresponding h/d equals 30 are m, n, and k, which can be obtained accordingly. This is just for one curve. Similarly, the same regression exercise is applied to other h/d ratios. Then the regression results are presented in this summary table. This is just a first run of regression. Then there will be the second round of regression. Now we can consider x as an independent variable. M, n, and k are dependent variables. We can now use polynomial regression method to determine the relationship between these sets of values one by one. Our goal is for our model to learn the underlying trend of the data, just like drawing an optimal line on an engineering graph. After the training, the relationships can be expressed as these equations. If you are interested in the Python scripts, you may make reference to these step-by-step procedures to perform the polynomial regressions. Here we go. Now we have found the missing piece. You may say I introduced additional equations and that make things more complicated. But think in this way. You just need to input these equations into your Excel spreadsheet once and for all. You don't need to measure on the chart and do interpolation anymore. It will save your time in future calculation. This is the graphical visualization of the above equations. It is a three-dimensional graph of 200 by 200 grid points. Now the gaps in between each individual line have been filled up. We don't need to guess the intermediate value in between individual lines. With a complete closed form equation in place, engineers can quickly estimate settlements without the tedious step of manual curve fitting and interpolation. It looks amazing, isn't it? To sum up, I started with a common geotechnical problem, the settlement of a shallow footing. I reviewed traditional chart measuring method. I introduced regression method as a means to derive a complete set of closed form equations. And finally, we walked through the basic steps of data preparation, model training, and prediction. That is a wrap-up for today's video on using regression method to streamline engineering practice. I hope you find this case study useful and that it inspires you to leverage digital tools in your own engineering projects. If you're interested in diving deeper, check out the additional resources on our GitHub repository and subscribe for more insights on engineering and AI integration. Thank you for watching.